Hello, everyone, and welcome to this special event. I can't tell you how excited I am to welcome Drew and Ryan back. They were our sponsors for episode 1, so it's really fantastic that they're back with us today to share some exciting news about their product. And you may have seen during the promotional materials for this event that Drew and the team also came to ML4Patents.com and asked us to help them with a focus group. And so, they were very impressed with this community, really excited to work with everyone the first time and show off their Relativity Patents product. And so much so that they asked a group of us to get together with them and talk through some of the things they had in beta and the direction they wanted to go. They were really excited about our feedback. And that is culminated in what we have here today, which is the first look at Relativity Patents version 2.0. And so once again, just a little bit of housekeeping. You'll notice in your control panel, there's an opportunity, a place for you to put your questions. Please go ahead and put your questions there if you have any. There are also 2 handouts, the slides from today and a little bit of promotional material from Relativity Patents. So if you didn't join us for the first webinar, there's a little bit of material there for you to look at. And there's a seminar at the end, there's a survey at the end. Only 5 questions, and the most important one is the first one. The guys are offering a 30-day free trial. And so the quickest way to get in contact with them to request your 30-day free trial is to go ahead and take part in that survey at the end of the webinar, and they'll get in contact with you right away. And without any further ado, I'm going to go ahead and toss this over to Ryan and Drew, who are going to tell us all about the brand new version of Relativity Patents. Guys, take it away.
Hey, thanks, Tony. Thanks for having us back.
Thanks, Tony. Can you guys see and hear me okay? I feel like I'm having issues with my webcam.
Yeah, I got to tell you, I mean, your lips aren't moving, but we can hear you. So your video is now stopped. But we can still hear you. So Drew's in New York City. He's attending a legal conference this week. And so just really thanks to him for being able to join us under adverse circumstances. We've all been in hotels. We know how spotty the Wi-Fi can be in those places. And so he's going to do the best he can. Ryan is also going to be doing a lot of the presenting. And so we really do hope between the 3 of us, we'll be able to make this a really smooth experience for everybody.
Yeah, apologies everyone. And if anyone is in New York for Legal Week, shoot me a note after. Would love to meet up. I switched to my integrated webcam now, so hopefully this helps a little bit. So again, yeah, thank you, Tony, for having us. The first thing we wanted to say is thank you to Tony and also to the whole community here. I mean, Tony's audience is like the most engaged set of people that we've encountered in any of our webinars or content that we do. So we love every chance we get to interact with all of you. I'm excited for today. We'll introduce ourselves a little bit. I'm Drew. I'm from Relativity, and I'm working on the patents product. Ryan, do you want to give your quick background just on a little bit of your history with Relativity Patents?
Yeah, sure. I mean, I started Relativity as in-house counsel, and then me and my buddy Evan he's still working as in-house counsel, but we're a growing software company, and we were kind of starting a patent program, maybe doing 5 or 6 a year, and realized like, man, this is hard. Like knowing the space, doing landscaping. I think Tony's going to talk about that a little bit later, like a framework that probably would have been helpful for us at the time, but we said, geez, we're an e-discovery software company. We make all these really cool search tools. Why don't we apply it to our own problem here? And that's kind of how the idea got started. And that was back maybe in 2015. And it was a very rudimentary version, just get the data in, index it. And since then, we've been in market almost a year now, and we've put a ton of time, ton of development effort. There's a whole team and a ton of positive momentum behind this product now. So for me, it's really cool. And I've since switched from being an attorney to now an engineer. And so I get to kind of have that job, which is way more fun. But yeah, no, so it's a good switch.
And as Ryan said, Relativity, the company, if you'd heard of us before this past year, it was probably in the context of our core product, which is e-discovery or e-disclosure, so supporting big litigation. But as Ryan said, we found that the same types of analytics, machine learning, and workflow that help us in that business are really applicable to like searching through the unstructured or semi-structured data that is, patents. What we really wanted to talk about today is something that we've noticed as we've been out working with our customers over the past year, since we were last in front of this audience, and that it's that the application of machine learning in the world of patent search and patent research has been uneven, and we have some opinion as to why adoption has been maybe slower than it could be, and it has to do with maybe just like reframing how machine learning can be used as part of a workflow, as opposed to thinking of it as a different workflow. So we'll get much deeper into that throughout the session. But first thing we're going to do is just really quickly recap what we shared the last time we were in front of Tony's audience for the core webinar series, which is awesome, and everyone should tune in. There's been a lot of good vendors and providers like sharing in that series. And then we're going to do, since this is a special session, we're going to spend a little bit more time on the actual workflow of our product, because we think it'll help illustrate A, what we're doing, but B, this perspective we have about how the machine learning can accelerate your workflow, as opposed to being tacked on at the beginning or tacked on at the end. And finally, we'll have plenty of time for questions and discussion. So please do put them in the chat if you have them. But Ryan, do you want to start with just a quick recap of last time?
Yeah, so Tony put together this kind of gold standard data set, which if you've been tuning into the regular series, you'll be familiar with by now. But basically, it's around quantum computing about qubits, and it's available there in GitHub. But basically, it's for classification. So we have it broken down here by families. There's 400 or something positive, about 1,000 negative, and that works out to like 5,000 total patents. So the idea is, can you train a classifier to correctly draw your hyperplane or whatever you're using to identify positive or negative examples? And Tony put some really tough ones in here, some tricky ones. And I think the space, Tony, right, is kind of notorious in and of itself for being difficult to search. But that was kind of the idea. Could you separate the wheat from the chaff with a control set, a known set of data? And if we go to the next slide there, we can just quickly talk about, so basically the way we do this classification is we map it conceptually. So that was that previous slide there. But basically each document gets mapped into a concept space, and then you can kind of draw a ball, a sphere, whatever that is, in n dimensions around it, and find things that are close to it. And that's kind of like your decision boundary. So that's our unsupervised approach. There it is there. And so you'll see certain documents become members of different classes this way. And you'll see we did this for these families over a few different sets of text. So we broke it down, like, let's look at only the abstract, only claim, only description, and then let's look at the entirety of the document. And we have our true positive, true negative rates there. So that's correctly identifying yes or no. And then we have the false positive, false negative rates. And that's where we made a mistake and misclassified something. And then gray is not classified. So then you work out precision and recall off of those numbers. And those are the lines on the bar chart here. And they're pretty good. They're right around 90%, which we were very happy with.
And we think, from talking anecdotally to some people in the industry, including Tony, we think that around 90 is about as good as a human expert would do in a space that they know pretty well. But for those in the audience that have, like, especially maybe people who are in-house at corporations that have a space you're looking at all the time, you can imagine, doing your own categorization and classification workflow with a system like Relativity. I'm sure there's others. I know there's others that do it. So we'll dig into more to that if we have time. But that's a quick recap. So we ran the data set that Tony generously shared with us. and a bunch of other vendors have too. Again, I encourage you to check out the whole series. Today, we wanted to talk more about like, okay, we feel from those numbers that we shared on the previous slide that these systems can be very accurate. But there's a whole different set of considerations when you get into the real world and start talking about practitioners. Like, we ask the question all the time when we meet with new customers or prospective customers, do you actually use machine learning in your workflow today? And even the ones who are quite enthusiastic, and people who are in this community and follow Tony and participate in these things, like they often say like, I don't actually use it on every single project. And when we ask why, it often comes down to time. So, when you think about applying machine learning to a real workflow, what people typically do is they either use it as a starting place. So, do a conceptual, semantic, or some other type of search. Get a big list that's prioritized and ranked, and then use that as a jumping off point. So gathering a big list as an alternative way of starting, as opposed to like a Boolean search. And then you might do further refining, forward and backward searching, things like that. But it's often just thought of as a different way to start. The other way people that we've talked to often use it is they do their whole search traditionally. Like, I look at class code, I look at the Boolean strings that I've collected over the years in my area, and then maybe I'll do one of these, machine learning workflows to try and just make sure I didn't miss anything. So comparing, see if there's any documents that float to the top that I haven't seen yet. And both of those things are really valid and a great way to apply the technology. We think there's a third thing that people can be doing that's more integrated to the way you normally work. So that's what we're going to show today and what we're going to talk about today. Before I jump into it, Tony, did you have anything you'd want to frame the discussion?
Let me address that, because that's something that I've written about and I've talked about, and I think is a really critical idea. Now, recently I was asked to provide a quote about the future of this industry. And the quote I provided was that in 5 years' time, machine learning methods are going to look the same as Boolean computer-based searches used to look to those people who were searching with punch cards. The quote was a little bit more eloquently stated, but the idea was that once upon a time, and this is really old school. I mean, this is like 30 years ago or more. That's the way patent searching used to be done. There were these huge punch cards, and that's where terms like false drops come from. The idea that a card that shouldn't have been a hit would fall out of this stupid machine. It was a false drop. That's why we still today call it a false drop. And so along comes the computer, along comes Boolean, traditional computational retrieval, information retrieval technologies, and it changes the whole industry. Again, the punch cards and the old way of looking through printed indexes. There's a number of us on this call who still probably remember looking through printed indexes, whether they be chemical abstracts or Beilstein or any of those other things. I mean, that was what was done, and not even so long ago. That we're talking about this shift takes place somewhere in the late 80s, early 90s. Okay, so again, about 30 years ago. And now machine learning is again that next advance, that next step forward. And so I've been a big proponent for the last few years about the difference between precision and recall. That machine learning, first and foremost, automatically right away could be used to help with precision. And using any form of machine learning algorithm in order to do a binary classification, to just like what you guys are saying, is this a yes or a no? Is it relevant or is it not relevant? The idea that you'd be able to apply even something as simple as that to a standard workflow is sort of groundbreaking, because today you're either doing a search where all you really want to see is 10 to 20 answers, 10 to 50 answers, very, very small set. You're using very, very dramatic methods to cut way down on things so that you're only manually looking at a very small number. And that's what some of the legal-based searches can sometimes be relying on, is generating a relatively small number that's highly precise. Meanwhile, there are other things that are just by their nature going to generate thousands. And how do you, because there's certain terms that you have to have, but they're ambiguous. And so you end up with literally thousands and thousands. And the question becomes, well, how in the world am I going to work with thousands? Well, there's plenty of us who are sitting here today who just like, well, I guess I got to slog. Yeah, I guess I got to, clear my calendar for the next couple of days, and I'm just going to have to slowly, and that's where this 88% sometimes come from the manual review. When people are having to deal with really, really large sets, your perspectives change as you go through them. There's all sorts of things that happen. And, ultimately you end up with something close to, between 88 and 93% accuracy from a human being. But the computer doesn't get tired. The computer doesn't change its mind about what the criteria should be, how its grading system changes over time. The computer doesn't do any of those things. And so the idea that we could, yes, in fact, take a huge search that's based on all the available different methods, a machine learning based, a natural language query, a Boolean based query, a citation based query, a classification based query, put it all together, and then at the end say, okay, well, we already know that there are 10 great answers and there's 10 answers that aren't so great, and then let's let the machine do the first cut, and then train it a little bit more and get it a better cut. And then eventually you end up with a relatively small percentage that maybe it's questionable, it's up in the air, and then you got to review those. So I love where you're going with this, and I can't wait to hear this third option. I probably talked too long there. Go for it.
No, not at all. And we have plenty of time to get into it. So what I thought we could do now is again, we're going to focus on this third one today, because we think we've really designed our workflow around this idea that we want to be able to integrate this machine learning as a tool in your tool set, in your existing workflow. And again, I think a lot of the resistance that we encounter to applying these things, even with people who are enthusiasts, is that it often can feel like an additional step. And we're trying to design our system so that it doesn't feel like an additional step, so that you have the full power of the machine learning for either ranking or classification, but you also have the full power of Boolean, the full power of filtering, the full power of data visualization. So you can start to like hone in on one workflow, one system that gives you the option to use the best tool for the job. So I'm gonna start the demo. Sorry, I saw a question about whether we're doing RCE credits for this. No, we're not doing RCE credits for this, but for those in the Relativity community, you'll know what we mean. Talk to us after, and we can try and set you up with the right resource to get those.
Oh, cool.
So let me flip over to my demo now. Give me 1 second.
Yeah, and while Drew's doing that, I guess I'll just motivate like where we're coming from. So yeah, Tony, you're right. I almost think of it like, sure, precision is one way, but like also expanding the set or being able to look at way more things. But then you still have the problem of having to review a lot of dense documents, and you kind of you have like a last mile problem in that you still need to read the patent. And that's kind of what we're trying to, when we say speed up your review, we're trying to like help you find out where in the patent is most relevant, and we can do that based on your kind of semantic query. And we'll see that in a second here.
Totally. I'm glad you mentioned the last mile problem, Ryan. So, whatever you do, right? Whether you are at a firm and you send the search out to a search firm, whether you're doing, class code or Boolean searching, whether you're using machine learning, at some point in a typical like prior art search or even a landscape, you're going to read some patents, right? And so part of what we're talking about when we say integrating the machine learning into your workflow is using it not just to do the ranking, which I'll get into here, but also to accelerate your decisions at the patent level. Is this patent worth my time to read? The machine learning, as Tony said, can do a really good job at telling you whether it's relevant in general, but it's not going to always tell you like what part of the patent that you should care about and how how close it is to the actual language that you need to see. So give me 1 second because I'm losing juice here. I'm just going to plug in. Sorry, I should have done this earlier. So what you're seeing on the screen here is relativity patents, and we're kind of going to do a left to right workflow. So what we started with is you'll see a claim. So imagine this one is more of like a validity search just for simplicity. We inputted a claim, we got a list of ranked results and a score. And we actually can do that with more than one query. So if I want to add another one, I can go up here, add section, and maybe there's a second patent that I care about. I'll pick claim one of that one too. So what's happening here, again, we're just going to build a big set to kind of start sorting through. And the machine learning is going to rank them independently. So for this EP patent, I've now added claim one as a second query, and you'll see I get an additional ranking. So why are we doing this with independent queries? Well, we want you to be able to sort and filter on a bunch of different criteria, not just one. And so now we have like a ranking that you can kind of play with here in the sort, and you'll see that each record, each patent, has a score for similarity to the first query and to the second one. I can also add write-in concepts. So maybe I want to, maybe I have a draft disclosure or something that I want to add. Instead of adding section, I can add just a write-in concept, give it a name, let's call it draft. So now I have a third column. But again, one of the reasons we see that this machine learning can sometimes feel foreign to people is they're used to also being able to just think in Boolean terms, and we can do that too. So I'll grab one more query that I had kind of ready. So now I'll add, we call it keyword, but it's really a Boolean string. So now I'm going to add like a filter. So I had a bunch of results that were conceptual, but now I have a keyword filter too. And I can say, hey, I can see if any of these hits that rank really well on my three concepts are also hitting like some Boolean string that I really care about. And I can filter for just those. So again, what we're trying to do here is make it a bit more intuitive to mix and match the machine learning and the traditional Boolean searching. When we're ready to go look at a patent, let me just pick one here that we can jump into. We also want to make it faster for you to review that patent. So that's where we think that we're trying to sort of push our users here to think of using the machine learning, as we said, in that third way, not just to get the list, not just to be a starting point or a sanity check, but to accelerate the pace with which you can move through a set of patents. So patent to patent, getting more review done in an hour. What does that look like to us? It looks like this snippet view here. So not only are we going to tell you which patent you should care about, but we're going to try to bring you to the part of the patent that reads well on your concept. And so you'll see this one, the EP hit has actually 21 snippets that the machine thinks are relevant. And this one happens to be with that first concept, the blue one. But if I expand the list here, you'll see some of them read on the yellow, none of them on the green. And we can kind of jump through this list and pick and read these in context and hopefully make a much quicker decision. Hey, should I care about this? Should I come back and look at this later? If so, I can save it.
Yeah. Let me.
I'll pause there, Tony.
Yeah. No, this is fantastic. Okay, so I am going to wax poetic because this is really exciting, and interestingly, not exactly the way you showed it. Okay, so I appreciate you going out on a limb and talking to this audience about this, but this is amazing for those documents that have multiple independent claims. And on top of it, those large extended families that have multiple components through a divisional, for instance, that are capturing alternate aspects of the invention through different family members. And being able to line all those up and then go ahead and suggest that, well, but here's the thing that's the real kicker. This is the Boolean hedge associated with the portion of this that we really think speaks to our novelty. And so therefore, and then being able to rank them. And what would be great, I don't know if you can do this. I mean, I'm assuming that the filters on the columns on your over claim draft, that those are one at a time. Now in Excel, you can do a custom sort where you can say sort by this, then this, then this, then this. That would make that, I mean, it's already extremely powerful. It's already really exciting to be able to see it this way. But then if you could actually say, well, yeah, the first item is the really, critical one. The second one is also really important, followed by the third. But then to be able to rank them by, well, here's a document that actually scores pretty well against all of them, because it was high here, but then it was also high here, and so on. And so being able to organize this way, yes, it's exciting. I can immediately see the ability. And of course, we've talked before, evaluation is the biggest problem probably that most people have with machine learning. How do I tell which results are the good results and why? And so they toss the systems because they struggle with this ability to be able to evaluate the results. And you guys are putting out a level of transparency here that's really excellent. So I'm going to question. Let me take a look at it real quick here before we go on. Yeah, so the question is very interesting. Are the concepts meant to be different? And I think you guys can answer, but it seems like it can be. It doesn't, it can be, independent claims that are important. It could be just about anything you wanted, right?
Exactly. It's just text. I mean, we have claims here because that's oftentimes the thing you're most interested in. So that's really like a user shortcut, a convenience. But really, you can type in your own text, or even it doesn't even have to be at the claim level, right? You could really, the inspiration for this kind of grid view came from, right, I have to kill independent claim 1, and here are the elements that I need to match up for like my mosaic. What's my best reference across all the elements? And so you could split the elements out into their own individual concepts and really extend this however way you want. But yeah, Drew's got 2 different independent claims from 2 different patents there, and then his text. So it can be anything.
And another way to answer that, if the question was asking like, are they meant to be conceptually different? These 3 examples, like why are they all kind of similar in number? It's just because I picked a random patent. I picked a claim that scored high on that first patent, and I picked an abstract from that first from there. So they're all quite conceptually similar, just because I happened to throw a few in. But if we wanted to add a new concept that might be different, let me just see if I can pick a random piece of text here. Here's just like a random part of this patent. I'm going to copy it. I'll add one more concept here just to see if I can show, one that scores a little bit differently. We'll see what the rankings are here.
Yeah, or another.
So now you'll see.
Yeah, you can be really parsimonious with it too, and put in something kind of opposite, and look for something that doesn't contain a certain concept. If you want a low score in a certain category.
Yeah, and you can do that if you're thinking about drafting. So we're trying different language to find things that actually don't read well on the art. We've had people use it that way too. But just to give an example, this record here reads well on that last piece of text, but doesn't read on the middle 2 concepts. So that's why it's blank. And so what you're seeing here is the differentiation. Like, hey, it kind of reads well on this one. It reads a little bit on that first concept, but not similar enough to where it would be judged as like scoring on the middle 2 concepts. By the way, the numbers, like we get the question a lot. The numbers are more for, I think of them as just a relative prioritization. 80 doesn't necessarily mean like anything in a vacuum relative to 70. It really depends on the search. So in some searches, and 95 is a really great score or similar score. In other searches, like a 75 is about the highest you'll see. So it just kind of depends. What we really want you to do is use the snippet view, again, to sort through and decide, like, hey, is this thing something that I should really spend time on? Is it going to be part of my argument if I'm, in the middle of a matter, or is it going to be something that creates risk or opportunity for me if I'm more looking at, licensing opportunities or more from an in-house portfolio building view? So what we really think here is like this way of having the machine assist you can speed up the decision about which things you should care about. Because no matter what we do with the technology, the expensive part of this process is always going to be your time. And so we're looking for more ways to cut down on your time, but increase the quality of your decision. Yeah, go ahead, Ryan, if there's more you want to add.
The setup here for the concept search was, I mean, you saw Drew he added 3 in the space of, 20 seconds. And if you're like a diehard, I just want to do my keyword search, I want to search by class code, you can, and you can just run the keyword search and we'll return a list to you. But add a concept and explain generally in your own word in a sentence or two what you're looking for, or just put in independent claim 1 because you're usually always looking for that. And then you'll just get the highlights for free. It'd be like a keyword search, and then you just have the highlightings as a shortcut to get to where you need to go in the document.
Well, that speaks to also the idea that one of the things that you're doing during this process usually is you're spending time looking at documents that come up as hits, and you're looking for alternate phraseology, alternate terms that different attorneys are using when they're drafting their patents. And so that's a perfect example of that. You put the words in, but you go ahead and do the concept as well, and then you look at a score that a document that scores well in the natural language processing portion of it, but didn't score well on your Boolean. And as you're looking at that, and you're saying, okay, so what is it about this and the way to describe this that was different enough that it didn't do well on Boolean? And as you develop that, you begin to be able to augment your Boolean searches as well. So, again, that's a pretty common technique that traditional searching uses with keyword hedges and things of that nature, where you're looking for these we call them hedges, but just these collection of synonyms, and how it is that you can go ahead and put it in, and it's going to do more help. It's going to help more than it's going to hurt, because of course that's always the boundary.
It's a really good point, Tony. I'm glad you brought that up, because I think that's something we should probably linger on for a moment here. Like why do you do a conceptual search, and why in our workflow do we suggest starting with the concept or the semantic? It's because we don't think that the future of this industry is going to be about, like, the Boolean thing should be a precision tool, right? Like, you don't want the success of your search to hinge on, did I come up with the right string? Because or the right synonym, like, no matter how good you are, how well you know your technology, you can't know how someone's drafting. And we know sometimes people draft in, sneaky ways and try to call something a module when it's really, something specific to an area of technology, call it a widget, whatever. That's where the conceptual search is really powerful. This Boolean string can then help us with precision or granularity if we need it, as a hedge, as you mentioned, Tony. But we really think that starting with the big basket of conceptual search results is a powerful way to think about this. And we suspect that one of the reasons this is, this type of technology isn't being used everywhere in every search team yet is because, it hasn't been combined into the right workflow yet. And we've seen this time and again in technology industries where something is around for quite a while before it gets mass, adoption. This group might be looking at us like, what are you talking about? Of course we use it, because you're in this audience, and Tony's audience is quite enthusiastic about this stuff. But we do talk to a lot of people who are interested but not quite sure yet, or not ready to let go of the crutch of the Boolean search. Like, we get the question, how do I know I'm done? And I know this is something, Tony and Ryan, you've thought about. So I wonder if you could comment on that one. How do I know when I'm done?
Well, before we get into that, there was one quick question I want to address, because you talked about scores, but we had a question came in that asked for not so much what the score means relatively, but is the score reflective of the method? I mean, they're asking, is it TF-IDF, cosine similarity, or something else? And so they're asking for, what it sort of algorithmically, where is it coming from? I don't know if you can address a little bit more about not the relative nature of the score relative to the other columns and the other documents, but just, where the score is coming from as far as the process of actually analyzing the documents.
Yeah, the score is cosine similarity. That's the short answer. And so two documents that were exact duplicates would have a score of 1 or 100 in this case. You can think of these as like percentages. And then documents that are diametrically opposed would be 0.
Okay, great. That's perfect.
Yeah.
And so the question you asked, Drew, if you want to repeat that for Ryan and I, and I'll go ahead and
Yeah, I think it's something that we get this question a lot. Like, in this particular example, we've now found 246 hits. And the question that I get a lot is, how do I know? Do I have to read them all? How do I know when I'm done? And I think that comes back to, it's really about, for us, your expert judgment is still the best tool to decide how to search and how deeply to go into each patent. So Tony, I was just curious, in your experience, we have a perspective that we're trying to set this up where you can have a good feeling for like when you've gotten to the end of your kind of, hey, now I'm getting to a point down at the bottom of the list where things seem less relevant. But in your experience, are there rules of thumb to kind of shortcut that decision?
Yeah, and working with this sort of a system and working with these sort of tools would definitely change my perspective, okay? Because today it's simple. You reach a point of diminishing returns, okay? It's easy to explain. You do the Boolean search, you do the classification search, you combine Boolean and classification, you do citation-based searching, you do the natural language processing, for instance, some sort of machine learning method. And so that's iteration 1. And then maybe you do iteration 2 of any of those combinations, okay? At some point, the percentage of relevant answers to irrelevant answers becomes skewed significantly from what you already have. So you're always taking those subsequent searches, comparing them to the collection that you've already discovered, and asking the question, am I finding anything relevant? Am I finding anything useful? And even then, there's a counter thing there where you're looking at, well, yeah, it's relevant, but do I care? And no, I don't, because what I've got is a pot full of these really great references, and none of them look as good, even close to any of those. And so after 1 or 2 iterations of that, you convince yourself that, look, I've come at this from 6 different directions. I'm not just typing 3 words into Google and hoping that I'm going to get something on the front page. That ain't what this is. This is a systematic approach from different angles. And at some point, you just don't get anything else really useful. Now, the drawback, of course, is that takes a lot of time. It takes a fair amount of work to go through those iterations. Even takes a lot of work to compare the lists and say that, yeah, okay, the ones I've already seen, take out. The ones that are left, now I'm going to evaluate. And so, yeah, it's really time consuming. It's necessary if you feel like you want to get to a certain level of comprehensiveness. But yeah, I mean, you're suggesting some ideas here about ways to do this that might really shorten and make that whole process more efficient.
Yeah, that was
Yeah,
kind of the whole goal with the grid view here, the list, is to see like what are the references that contain everything that hit on all, because obviously like we're searching, it's information retrieval, we're going to pull back stuff that's relevant to any one of these concepts. But if you can visualize in a way like, where are my winners in terms of all the points I need to cover, and then does it have the keywords I'm looking for? And you can see on this list, Tony, your diminishing marginal returns, right? You'll see a lot of these start dropping off, that they're not scored on some of these searches because they're below our cutoff. And so even though the keyword search, these are yeses, they come back and you'd have to read them, you can see right away, okay, I have maybe 10 families I need to look at here. And then snippet view is, get me through those families faster and let me make that decision. So, I mean, ultimately, the definition of done is going to be up to you, but we're really just trying to put like the power in your hands to make that a little more visible.
Yeah, and we do get that. And Tony, I totally agree with what you said, and Ryan too. When we get that question, that's exactly what we say. It's like, hey, you're still the expert, but if you don't have some sort of machine learning capability in your tool set, we think you're going to spend a lot more time, right? You still need to be thinking about Boolean in some cases, class codes in others, forward and backward searching, all that stuff that Tony mentioned is important. But if you don't have this ability to sort of see what the machine thinks, as Tony said, the machine never gets tired, never has a bad day. We think that it's increasingly going to become imperative for for people who have like a serious responsibility to have their own, insights into their portfolio, or if you're a firm and working on behalf of your clients, that you'll have something like this. So we obviously believe that. We have a strong feeling that's the case. But it's on us as vendors to make this easy enough that you can actually use it, and that it doesn't feel like you're doing every search twice. So again, what we're really hoping that we can achieve here is making it easy to do this in your existing workflow. There's plenty more features that we need to add that will be coming, but this community can really help us, right? Like tell us what else you need to make this your go-to approach, or if it's something that you couldn't see yourself using, we'd love to hear that too. Please do get in touch with us. Like as Tony said at the beginning, we've absolutely loved working with this audience. We've learned so much from you, and we're really trying to build your dream tool here. So we'd love to hear how close we are. I know we're coming up on like the 45-minute mark. People might be
comment on what you just said, and 3 questions in the queue. So let's go ahead and do that, and then if there's a few additional things you want to do at the end, we've still got time. Everybody's hanging on. Everybody's here with bated breath. That we just about everybody who started with us is still with us, but it is still not uncommon. That the primary mode of evaluation is what everybody refers to as reverse chronological. Okay, that is a default for many systems. That the answer set that you're going to get back is sorted no other way than by the most recent documents first. All right, and that is a slog. That is not helpful at all. All right, and so just getting beyond reverse chronological is already a significant step forward. So, okay, with that comment, so let me just ask these. These are great questions. I think you guys are gonna, you're gonna enjoy talking about them. How does a user of this tool share information from this tool with a group of colleagues who may be located at different facilities?
Yeah, it's a good question. So it's a cloud-based system. What we hope is that a lot of the collaboration is happening in the tool. So when I save something, Ryan can log in and see what I've saved. There's one other feature that I'll tease here and not spend too much time on, but I can also draw my own highlights. So if I find something that the machine hasn't found that I think is important, I can associate that with one or more of my concepts. And again, Ryan can log in and see these on my chart. What's coming here soon is the ability to export this as a claim chart. So maybe more relevant for the attorneys on the call, but we actually want you to be able to walk away with an exported claim chart with each snippet associated with the concept here, color-coded just like you would in your, if you're doing that manually. So we do have ways to export the data, but we also have a lot of ways to collaborate in the system with multiple users, and they can be anywhere. I hope that answers it.
Yeah, that's great. That's exciting. That'll be good to see that in the claim chart. Second question, having to do specifically with IPC CPC. And I guess I think this is the way the question was phrased. This is the way I would interpret it. When you have that add concept portion, can you add an IPC CPC code concept as such so that it would do some sort of homology or start matching up which documents have the most codes in common, and be able to do so that you've got your words basically, but then a code-based mechanism of being able to look at the similarity between 2 documents.
Yeah, so that wouldn't be a concept. It would be, we call that like a Boolean or a filter. So we just have the keyword here today, but we have access to the IPC and CPC. So you could just add, like, I want to see it's instant class Geo6F, and that could be another column that says yes. Maybe the more interesting thing would be to go through the class definitions. Like, I know those are published and kind of semi-regularly updated. And you could take the text of the class or the subclass you're looking for and put it in. But honestly, the better thing to do there is probably find a couple documents, like exemplar documents from that class, and pull their text too. But short answer is it'd be like the keyword thing.
Yeah, to be super clear, like you can filter on class codes too.
Okay, and then this last question for now, and again, we're at 45 minutes in. We want to be respectful of everybody's time. We'll continue working through the questions. We'll continue to talk about a few more features, but please, now's the time to put questions in. Can you share a little bit about how the system works with regards to a chemical or a biological entity type searches? Because those are two very specific areas that traditionally struggle to a certain degree with keyword or term-based approaches, because we all know the nightmare that chemical name fragments become and things like that. So do you have any? What would you tell your client if it's somebody from a chemical company asked you about this system?
Yeah, to be super honest, we don't have a specialized compound search or ring search, as some call it. We've had customers do chemical or biologic with the concept search and the Boolean and get decent results, actually get surprisingly good results. But the concept search is not always the best tool for that chemical stuff. If, and I'm not a chemist, but it's going to pull back things that look similar enough, but that are to a chemist completely different in some cases. So what we'd love for you to do is try it. What we have found, and we've talked to some really big companies that do primarily chemical type searches that have gotten a lot of utility out of this tool. So I think, again, it comes back to knowing the tool for the job. And we've found, plenty of searches where text-based is quite useful. But if you know that the actual compound is something you need to be able to find, and you don't think you can get there with a Boolean in a simple way, it might not be the best tool for that job. I don't know, Ryan, if you had anything you wanted to add.
No, I mean, it's basically under the hood that the name of the chemical or that symbol is going to get tokenized. And so it's still going to be treated like every other token. A token is basically a word that's been kind of compacted. But that process, like Drew said, may turn it into something that's a little bit different. But the two of us would look the same. But yeah, I'd say give it a shot.
What we're saying is maybe not today for composition of matter. Okay, so we're looking to see if this is a novel substance as such, but it could absolutely be used for functionality. For what it is that this substance is doing, acting on, behaving as. So it certainly should be able to help with regards to the function of the substance, if not the novelty of the substance in and of itself. So
yeah, you put it more eloquently than I could, Tony.
Well, thank you, but I'm a chemist. Actually, I ought to be able to. I've worked at, if I can't talk about chemical substance searching, it's a bad day. All right, so again, questions. Also, survey. Please don't forget, the first question in particular. The other ones are similar to the ones we do with all the other surveys. We'd really love to hear what you thought. The pacing, the content. That's how we encourage the sponsors to really invest in the time that they put all this together. So Drew, Ryan, is there anything else that we want to talk to? We've run through the questions. We're at 50 minutes. Everything's going exactly to plan.
Yeah.
But anything else you want to share with us?
Yeah, we can close it out. I think, again, a huge thank you. This is just super exciting for us to be with Tony and this audience. I know I keep saying it, but we've gotten a ton of value out of it. So thank you for those who have engaged. For those who want to try it, please email us. We'll probably reach out, post survey, just to give you a little bit more information, a chance to touch base. The last thing I'll say is there's two things we'd really love people to try right now that we've kind of just released. One was the little claim charting feature that we're very excited about, especially for attorneys. If there's one thing we found that gets attorneys animated, it's asking them how much they like making claim charts. It's something people just find very tedious. So if we can automate part of that process, we think, again, we can really help you speed up your work. For the more in-house searchers and the patent information professionals, We'd love for you to try this tool on a search project or a categorization project. And we'll kind of be there with you throughout, kind of helping you set it up and interpreting the results. Everyone we've done this with has improved the product, and we think it's been valuable to the people who have tried it. So please do stay in touch. You'll hear more from us on future webinars with Tony, but in the meantime, we hope to meet a bunch of you in person or on like the Zoom. Ryan, I'll give the final word to you.
I think you nailed it. Like, look, we're patent people. We work at a software company, but like this tool was built by basically surveying a bunch of patent people over the course of maybe 18 months and asking like, what do they want to see? And we are very approachable, and we're not afraid to try something. And we're not afraid to admit when it doesn't work either. But that's how we've gotten here, and that's how we'll continue to build this thing. So.
That's fantastic. I mean, that's certainly been my experience. I mean, Relativity, the parent company, has the resources because it's a much bigger organization, and they've seen that this patent speciality, this patent vertical is really critical, and there's an unmet need. So you've got the resources of a big company, but the focus and the desire to really satisfy this vertical. And I think that's a really outstanding combination. And so, again, thank you. Again, the survey, please fill out the survey, and we'll have these guys back as they have more and more exciting news to share with this audience. And I'll be in touch. I'll be sending out announcements for future webinar series content. We're looking at one at the middle of April at this point. The schedule has become a little bit fluid because some of the people that we have scheduled, the industry is moving so quickly that things are going on, and so certainly be in touch with regards to what's up next for the series. But again, Ryan and Drew, thank you so much for being here today. Thank you everybody for listening, and again, anytime you have any questions or if there's anything else that we can do, please don't hesitate to reach out. And with that, everybody have a great rest of your day.
Thanks, Al.
Thanks again.